Hello everybody, welcome back to Unit 3. Hopefully you had a chance to watch yesterday's video, which was Unit 3 Lesson 1. It was all about parallel and skew lines. If you have not yet watched that video, stop. Go watch that one first. This is the follow-up to that lesson. So make sure that you've watched the Monday video that was Unit 3 Lesson 1 on parallel and skew. Once you've done that one, this is day 2. Okay, so first things first, let's answer these two questions. What is the geometry definition of parallel lines, and what is the geometry definition of skew lines? So again, that's from yesterday. Let's recall what we mean in geometry when we say parallel versus skew. And don't stop at they don't cross, because that's true of both types of lines. In geometry, we have to be much more specific. Okay, so hopefully you remembered yesterday the difference. Parallel is what we have been working with for a very, very, very long time. When we have parallel lines, that means that they have the same slope, or sometimes we say that they don't cross, okay? But more specifically, we could say they have the same slope. But in geometry, it's important to note they are in the same plane. In other words, they are both on the same sheet of paper, or they're both on the same wall, or they're both on the ceiling or on the floor, whatever. They're both in one two-dimensional space. That's different from skew, because in skew lines, they still don't cross, but they're not in the same plane, right? So we saw lots of examples yesterday where there's like a 3D shape. And skew lines might be something like a line that goes, if I can find my pen, across here, and then a line that goes up and down across the back. Right? Those two lines are never going to cross. But this line, this one on the front, is in the plane. It's in the plane of the front of the box, and it's in the plane of the top of the box. This line back here is in the plane of the side of the box and the back of the box. They're not in the same plane, and that's why they're never going to cross. If I took this line and I moved it up to be in the plane here in the front of the box, they would definitely cross. The only reason they're not crossing is because they're not in the same plane, and that is what we call skew lines. Okay, so today is going to be a little bit of a short one. I need to introduce some terminology to you, so that tomorrow we can all be on the same page as far as what we're talking about. We're going to start talking about a lot of angles, new angle relationships in this unit, and in order to do that, we have to talk about how those angles are formed and where those angles came from. So we already know things like vertical angles and complementary and supplementary and adjacent, and we're about to get more relationships added to that. Just in time for Valentine's Day. Isn't that sweet? All these angle relationships. So nice. Okay, so I put a note outline for you that has this and several pictures in Schoology. So if you want that, you can go ahead and print that to use to take notes. Take a pause for the cause if you need to. Okay, the word of the day that I need to introduce you to is this word right here. The word is transversal. And a transversal is very simply a line that just happens to intersect or cut through at least two other lines. Okay? So if you're a line and you're chugging along, you know, going on for infinity in both directions as lines do, and you cross another line, you're still just a line. The instant you cross a second line, you just became a transversal. Okay? Now, cross a third line, you're still a transversal. Cross a 10th line, you're still a transversal. I don't care if you cross 100 lines, you're still a transversal. There's no other promotions when it comes to being a line. Okay. So some lines don't cross any other lines. We don't even give them a name. Okay. Some lines just cross one line. Okay, do your thing. As soon as they cross two, they become a transversal, and then they can keep crossing lines all day long. They're still a transversal. The criteria is that they cross at least two lines. Okay. So in this picture, there are 3 lines here. There's line L, there's line M, and there's line T. Only one of them is a transversal. And you might be able to figure it out based on the letters. Geometry, mathematicians think they're so clever. Okay. Notice here, line L, if you follow it, only crosses through line T. Line M, if you follow it, only crosses through line T. Those aren't transversals. Guess what? Who is? Oh, the line that we cleverly named T for transversal. Notice that line T crosses line L, and then it keeps on trucking and crosses line M. That, my friends, is a transversal. So here we would say, why can't I ever find my pen? We would say T is a transversal that intersects, we could say, or we could say cuts through or passes through, whatever, L and M. Where'd my L go? Right. So if you're going to call something a transversal, you better be able to name at least 2 lines it cuts through. If there's 3 or 4, good for it, but there better be at least 2. Okay, so let's take a look at a picture down here. All right, so again, this first bullet here is just a restatement of what we already said. Any lines that cut through 2 or more. I wrote more, you get me. Anytime it passes through 2 or more, it's called a transversal, but that name is reserved for when it cuts through 2 or more. Right? And what's even more important to us is, what do I care if it's transversal, right? Because when a line is a transversal, every time a line cuts through a line, every time a transversal cuts through another line, it creates a little, I call them clusters of angles. It creates 4 angles. We're used to seeing these because we're used to seeing lines that cross, right? When we see 2 lines that cross, we know there's 4 angles there. But now that we're talking about transversals, we're going to see clusters of angles. So I'll show you what I mean if I can get my mouse to click. What's going on? All right, so here's a line. It's red. I didn't even name it. I'm just going to call it red line. Here's another line. It's yellow. It doesn't have a name. I'm just going to call it yellow line. And I'm going to move my floating head. I don't have to tell you that another line is about to come through. His name is transversal, and he's blue. It's anticlimactic, to say the least. Okay, now, I'm no art teacher, but I do know a few things from reading kids' books and doing science with my kid, right? So I was very clever with my colors here. Brace yourself. Okay, when blue line comes and cuts through red line, red and blue make purple. So notice here that when blue line hits red line, I get a cluster of 4 angles. I'm going to come in here and I'm going to name them. I'm going to name them 1. Whoops, I didn't mean to do that. I'm a mess today. Give me my pen back. Okay, I'm going to name them. I'm going to call them 1, 2, 3, and 4. Right? And we already know some relationships here. 1 and 3 are vertical. 2 and 4 are vertical. We would say 1 and 4 are adjacent. You could also call them supplementary or a linear pair. 2 and 3 also adjacent. 1 and 2 are adjacent. 3 and 4 are adjacent. There's all kinds of angle relationships here that we already know. Right? But transversal doesn't stop there, right? He's like, no, I'm a transversal. I must intersect another line. So transversal keeps on trucking. He comes down here. He crosses through yellow line, and yellow and blue come together to make, boom, a green cluster of angles. So now this blue line has made a cluster of angles up here. He keeps on going. He makes another cluster of angles down here. I'm going to call them cleverly 5, 6, 7, and 8. Same relationships here as we saw up here. I have vertical angles 5 and 7, vertical angles 6 and 8, and then I have all these pairs of adjacent angles 5 and 8, 8 and 7, 7 and 6, 6 and 5. Okay. But it's the same deal as up here. What we're going to start doing in this unit is looking at relationships not within a cluster, but relationships between an angle, say, in the purple cluster and an angle in the green cluster. And transversals are how we're going to relate an angle in this cluster to an angle in this cluster. If you can find a transversal that connects two clusters, then there's all kinds of fun magic that happens between them. And there's going to be new relationships, new angle relationships, like I said, just in time for Valentine's Day. Okay, so all I want us to talk about today is how to recognize a transversal and find the clusters of angles that it creates. Tomorrow, when we get together, we're going to start talking about the actual relationships, the actual angle relationships. But in order to do that, you've got to be able to find your transversal and find the clusters of angles that it creates. So if you look at the note outline I gave you, and you're going to see the same diagram 4 times, there's a reason for that. Okay, so in that first diagram, let's write this sentence and you can fill in the blanks. Okay. L is a transversal that cuts through blank and blank. Okay. So write that down and fill in the blanks, and then I'm going to ask you to answer that question on here. Okay, so let's follow L. As it goes along its path and see where it creates some angles. Okay, so here's line L. Let's follow it. There we go right there. Look, it crossed through G. It created a cluster of angles. So L is a transversal that passes through G. I keep going, I keep going, I keep going. Boom! It does it again. It crosses through H. Okay, so let that go away. I can say that L is a transversal that cuts through G and H, and I can say that because, again, it cuts through 2 lines, so I'm officially calling it a transversal, and it passes through G, it passes through H, and again, I cannot stress enough. As soon as it passes through G, it creates a cluster of angles. When it passes through H, it creates another cluster of angles. And what's important for us to note here is that those clusters of angles are connected by L. I always think of them as like little towns. Like there's like Purple Town and Green Town, and L is the road that connects them, right? Or like a train. It's the L train. It takes us from the Purple Town on over to Green Town. Okay, let's look at another one. Okay, go ahead and give this one a shot. Write the sentence down, and then I'm going to ask you to fill in your sentence here. All right, so M is a transversal that cuts through blank and blank. So let's find M. Okay, here we go. M. M. Boom, cuts through K, creates a cluster of angles. M continues, cuts through T pretty quickly thereafter, creates another cluster of angles. So again, I've got a cluster of angles here. I've got a cluster of angles here. I've got a purple group of angles and a green group of angles. The road that connects them, the train that connects them, is the M. That's important. So we can say that M is a transversal that cuts through K and T. Did you get it? I hope so. Okay. Next. Woo! G is a transversal that cuts through blank and blank and blank. So here we go. It doesn't just have to be 2. It could be more than 2. It could be 3. It could be 4. It could be 5. So let's follow G and talk about where it creates clusters of angles. All right. So here we go. G, let's follow it. Boom. Cuts through L. Creates a cluster of angles. Keep following it. Boom. Cuts through K and creates a cluster of angles. And then we can keep going. Boom. Cuts through T, creates another cluster of angles. Right? I want you to notice something here. In the first problem that we did, L was the transversal, right? L was a transversal that cut through G and H. Here, L isn't the transversal. It's one of the ones that's being cut through. Okay? So lines can be both depending on the situation. Okay? So I could say here, we said that M was a transversal that was cutting through K and T, but it's also true that K is a transversal that's cutting through some other lines. So if a line is a transversal, that doesn't mean it can't be cut through by other ones. And if a line is being hit by a transversal, it doesn't mean it couldn't also be its own transversal. All right, last one. Ready? Go for it. Okay. K is a transversal that cuts through, and again, we have 3 blanks here. I almost gave myself away in that last one. I literally almost went over this one in my head by accident. Okay, here's K, right? Let's go. Chug, 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 chug. It hits M, it creates a cluster of angles. Keep on trucking, keep on trucking. It hits G, it creates a cluster of angles. Keep on trucking, it hits H and creates a cluster of angles. Let me move my head again. Okay. All right, so again, look, K hits boom, boom, boom. 3 lines. So this is a transversal that cuts through M. It cuts through M, then it cuts through G, then it cuts through H. Okay, so if you're going to call something a transversal, you need to be prepared to answer 2 questions. What lines did it cut through? And you better have at least 2. And where are the angle clusters that it created? I want you to be able to mark them off. So tomorrow we're going to be in Desmos and we're going to do some color coding to make angle clusters. Okay, for now, just give me any questions that you have on transversals at the end of this, and I will see you tomorrow. Have a good night.